December 5, 1945, 2:10 in the afternoon. 5 Avenger torpedo bombers take off from the Fort Lauderdale Naval Air Station, Florida, on a routine training flight, 2 hours in duration, clear sky, 14 men on board. Less than 2 hours later, the instructor in command reports by radio that none of his compasses works, that he does not recognize the coast, and that the ocean does not look as it should look. That afternoon, Flight 19 disappears without leaving a trace. The seaplane sent to search for it also disappears. Since then, that stretch of ocean that links Miami, Bermuda, and Puerto Rico has carried a name built in equal parts from verifiable facts, transcription errors, and editorial manipulation: the Bermuda Triangle. Unlike what its century-old fame suggests, the term Bermuda Triangle has an author and an exact date. It was coined by the writer Vincent Gaddis in February 1964 in an article in the pulp magazine Argosy titled "The Deadly Bermuda Triangle." Before that article, the shipwrecks and disappearances in the area had been reported for more than a century as isolated events, with no connection to one another. Gaddis was the first to gather a dozen cases under a single narrative umbrella and give them a name. The article worked so well that he expanded it a year later in his book Invisible Horizons. Other authors followed him. John Wallace Spencer published Limbo of the Lost in 1969. But the real commercial trigger came in 1974 with The Bermuda Triangle by Charles Berlitz, a bestseller translated into dozens of languages and sold by millions of copies that definitively installed the myth in popular culture, mixing documented shipwrecks with theories about Atlantis, dimensional portals, and UFOs. A year later, in 1975, the answer appeared. Lawrence David Kusher, a reference librarian at Arizona State University, had spent 3 years tracing primary sources: archives of the Coast Guard, the Navy, Lloyd's of London, and the complete index of the New York Times since 1851. The result, the Bermuda Triangle mystery. Solved, reconstructed the original documentation case by case, and found that a large part of the facts repeated by Gaddis and Berlitz did not hold up, had been altered in successive rewritings or directly invented. Even the supposed oldest origin of the mystery turns out, when reviewed closely, to be less supernatural than it is told. Christopher Columbus noted in his 1492 diary that his compass deviated strangely and that his crew saw unusual lights in the sea while crossing the Sargasso Sea, within the limits that some authors assign to the triangle. What later versions omit is that this magnetic deviation is the normal variation of any compass, predictable and charted today on any navigation chart. Columbus was simply crossing, for the first time for a European, the line where true north and magnetic north coincide, something that will be explained in detail later. The area itself never had official boundaries. It is usually drawn as an approximate triangle between Miami, Bermuda, and San Juan, Puerto Rico, about 1.3 million square kilometers, although each author extends it or shrinks it at convenience. It was also known as the Devil's Triangle, the Limbo of the Lost, the Hoodoo Sea, the Twilight Zone, or the Port of Lost Ships. That geographical elasticity, as will be seen later, proved key so that the catalogue of cases could grow indefinitely. Berlitz's book, moreover, was not limited to shipwrecks. Written together with the zoologist J. Manson Valentine, it incorporated underwater rock formations found off the island of Bimini, interpreted by Valentine as possible architectural remains of a lost civilization, and presented them as complementary evidence that Atlantis could have existed in that same region, leaving behind energies or technologies capable of interfering with modern ships and airplanes. The geologists who later studied those formations, known today as the Bimini Road, identified them as beach rock, a type of natural cementation of coastal sediments that forms without human intervention and appears on other coasts of the Caribbean and the Mediterranean. The Atlantis hypothesis never had geological support, but it functioned as narrative glue between the catalogue of shipwrecks and the imaginary of lost civilizations that dominated a large part of the mystery literature of the 70s. On December 4, 1872, the Brigantine de Gratia sighted a 282-ton sailing ship navigating erratically with no one on board in waters located between the Azores and the coast of Portugal. Thousands of kilometers from the Bermuda Triangle, that ship was the Mary Celeste, and it became the most cited ghost shipwreck in naval history, systematically included in the list of Triangle victims, despite having disappeared in another ocean. Captain Benjamin Briggs had set sail from New York on November 7th, bound for Genoa, with his wife, his daughter, and 8 crewmen. When the Dei Gratia found the ship a month later, the sails were set. The only lifeboat was missing, which seemed to have been deliberately lowered, not torn away by force. The cargo of 1,700 barrels of industrial alcohol remained almost intact. The captain's logbook was on board, but the navigation instruments and the ship's papers were missing. The salvage investigation in Gibraltar was never able to determine what had happened to the crew. The most famous details of the account do not appear in any official report of the time. They appeared for the first time in 1884 in a fiction story signed anonymously in Cornhill magazine by a young doctor named Arthur Conan Doyle years before creating Sherlock Holmes. Doyle renamed the ship Marie Celeste and constructed a literary version so attached to the real facts that many readers believed it was journalism. That confusion was never fully corrected. Much of what is repeated today about the Mary Celeste comes from Doyle's fiction, not from the case files. The most accepted explanation today combines bad weather, rough sea that could have filtered water into the hold and generated panic at a possible sinking, and alcohol vapors escaping from the barrels that could have made them fear an explosion. Everything indicates that Briggs ordered the ship to be evacuated in the lifeboat as a preventive measure, probably intending to remain nearby by means of a tow line. A storm or the breaking of that mooring would have separated both vessels, condemning the crew on the high seas while the Mary Celeste continued drifting, empty, for another month. In April 1925, the Japanese steamer Raifuku Maru set sail from Boston bound for Hamburg, loaded with wheat. On the morning of the 19th, already in the middle of the Atlantic, it sent a distress signal that was picked up by the ocean liner Homeric of the White Star Line about 70 miles away. Shortly after, a second message arrived reporting that all the lifeboats had been shattered. The last, in rudimentary English, simply said that the danger was very great and asked them to come quickly. The Homeric forced its engines to 20 knots toward the indicated position, about 600 kilometers east of Boston and more than 1,100 kilometers north of Bermuda, far outside any reasonable definition of the triangle. When it arrived, it found the Raifuku Maru listing 30 degrees and unmanageable in a sea of enormous waves. The crew of the ocean liner tried to approach to rescue survivors, but no boat could hold in that swell. The 48 crewmen of the Japanese ship drowned in sight of those who were trying to save them. There was no disappearance or inexplicable silence. There was a documented storm, a call for help heard and answered, and a tragedy that the captain of the Homeric himself witnessed in real time. The versions that circulate of the case usually cut the account just before the arrival of the Homeric, turning a tragic but perfectly recorded shipwreck into a ghostly disappearance. Something similar happened that same year with the freighter Cotopaxi, which set sail from Charleston bound for Havana at the end of November loaded with coal and stopped responding to communications at the beginning of December. The records of Lloyd's of London place its last transmission just when a storm described by the Weather Office of the time as phenomenal was striking the Atlantic coast of Florida and Georgia, with winds of more than 100 kilometers per hour that forced other ships in the area to take shelter in port. The Cotopaxi was not even mentioned in the press coverage of those days. Its loss was treated at the time as one more among the predictable victims of an end-of-year storm. Only decades later, when some authors in search of new cases for their triangle lists reviewed old Lloyd's files, did the Cotopaxi become part of the catalogue of disappearances without explanation. On March 4, 1918, in the middle of the First World War, the USS Cyclops set sail from Barbados bound for Norfolk. It was a United States Navy collier of 19,600 tons and 165 meters in length, one of the largest ships in service, with 309 men on board and a cargo of manganese ore. It never reached its destination. It sent no distress signal, not a single piece of wreckage was found. It remains, more than a century later, the greatest loss of life in the history of the United States Navy outside direct combat. The first hypotheses pointed to a German torpedo attack dismissed after reviewing, after the war, the naval records of the German Empire. There were no submarines operating in the area on that date, and Germany usually publicized the sinking of large enemy ships as propaganda, something it never did regarding the Cyclops. A mine was also considered, but that type of impact usually leaves time to send for help and leaves wreckage floating, and none appeared. An overload of the cargo was suspected, but the foreman who personally supervised the stowage stated that the ship could have transported 2,000 additional tons without risk. Even President Woodrow Wilson himself publicly commented that only God and the sea knew what had happened to the great ship. One fact that popular versions usually omit is that the Cyclops was sailing with a damaged engine, reducing its speed to barely 10 knots. Calculating that speed against the North Equatorial Current and then the Gulf Stream, the ship should have been approaching Norfolk around March 10th. When the archived meteorological records of the National Climatic Center were reviewed, it was confirmed that on that very day a violent storm struck the coast of Virginia, with winds of up to 97 kilometers per hour, which went almost unnoticed at the time because public attention was focused on the European War. A nearby ship, the Amolco, had to ride out the same storm for 2 days and suffered considerable damage. One of its officers stated some time later that he was convinced that that storm had sunk the Cyclops. Decades later, a Navy diver named Dean Hawes located off the coast of Virginia an unidentified wreck with an unusual structure, an engine room raised on steel pillars, which matches the particular design of the Cyclops, although it was never officially confirmed that it was the same ship. The initial search, however, was mistakenly concentrated near the Caribbean, where the ship had set sail, and not near its destination, where, according to the later reconstruction, it probably sank. That decision, added to the fact that no media outlet of the time linked the storm of March 10th with the disappearance of the Cyclops, explains why an episode with a reasonably identifiable meteorological cause ended up appearing for more than half a century among the most cited enigmas of the ocean. If a single episode turned the Bermuda Triangle into a mass phenomenon, it was Flight 19. The complete sequence of radio messages, preserved in an official report of more than 400 pages, makes it possible to reconstruct what happened with a detail that most of the other cases lack. The flight plan was simple: 160 miles to the east, 40 miles to the north, and back in a straight line to the base. A triangle of a little more than 300 nautical miles in total. At 3:45 in the afternoon, when they should have been requesting landing instructions, Lieutenant Charles Taylor, in command of the formation, reported by radio that neither of his two compasses was working and that he could not identify the coast below. He believed he was flying over the Florida Keys, south of the base. The later evidence, including testimony and the available radar tracks, indicates that the formation was in fact much farther north and east, near the Bahamas, probably around Walker's Cay, about 60 kilometers north of Grand Bahama, after having deviated from the route earlier in the exercise. Taylor had years of experience flying exactly over the Keys in previous assignments. That familiarity may have worked against him when, now flying over a different archipelago that he did not recognize, the islands of the Bahamas, he confused them with the Keys he knew by heart, and that mistaken conviction led him to order headings that, instead of bringing the formation closer to Florida, progressively moved it farther out to sea. Lieutenant Robert Cox, who maintained brief radio contact with the fleet, reported that the sea below was very rough, covered with foam. After 4:30, Taylor decided to turn northeast for 45 minutes before turning north, reasoning that this way they would avoid ending up over the Gulf of Mexico. That decision moved them even farther away from the mainland. The weather, far from the perfect calm described by popular versions, had worsened. Winds of 40 to 55 kilometers per hour, cloud ceiling between 250 and 360 meters, turbulence and intermittent rain. Another instructor who was listening to the frequency from his own aircraft tried several times to guide Taylor so that he would activate the radio direction-finding equipment that automatically indicated the heading back to the base. He never received a clear answer. Port Everglades even suggested to him by radio that he hand over command to any other pilot in the formation whose compass was working correctly. Taylor answered only, "Received," and nothing changed. Around 7:30 in the evening, a Martin Mariner seaplane with 13 crewmen took off to search for the lost formation. 23 minutes later, the crew of a tanker, the SS Gaines Mills, reported having seen flames in the sky followed by an explosion over the sea, almost exactly in the position where radar had last tracked the Mariner. The investigators concluded that the seaplane probably exploded in mid-flight. That model accumulated fuel vapors in poorly ventilated compartments and had known records of fires and explosions, to the point that some crews nicknamed them flying gas tanks. No trace was ever found of the 5 aircraft of Flight 19, of the Mariner, or of the 27 men who were on board both, despite a search that mobilized hundreds of ships and aircraft for weeks. The naval investigation, after months of work, was unable to determine a cause. One of the officers in charge summarized the frustration of the court with a phrase that was later repeated in every new version of the myth. He said that they had disappeared as completely as if they had flown to Mars. Contrary to the image of calm sea and inexplicable technical failures repeated by popular versions, the original documentation shows rough sea, sustained wind, low cloud cover, and a clear chain of human error. A formation leader increasingly disoriented who, despite the suggestions of other pilots to fly west following the sun, chose headings that took the fleet farther and farther from land until the fuel ran out over the open sea at night, with the weather deteriorating and with no real possibility of rescue. The popular belief that the Navy keeps still in force a special alert order because of the cases, like many other details, a later addition without documentary support. On January 30th, 1948, the Star Tiger, a 4-engine Avro Tudor IV of the British airline BSAA, disappeared in flight from the Azores toward Bermuda with 31 people on board, shortly after transmitting a routine message reporting that everything was fine. Not a single piece of wreckage was ever found. Almost exactly 1 year later, on January 17, 1949, its manufacturing twin, the Star Ariel, disappeared on a flight from Bermuda to Jamaica with 20 people on board, again with good weather reported, again without a distress call, again without recovered wreckage. The official British investigation in charge of the Ministry of Civil Aviation questioned pilots, reviewed technical records, and found no common mechanical pattern between the two cases. The final report admitted that it could not determine the cause and attributed the loss to some external cause without specifying which. What was known, and is rarely mentioned in the versions of the legend, is that the Tudor IV carried previous crew complaints, heating problems, fuel consumption that left tight safety margins on long stretches over the ocean, and observations about the weight balance of the airplane. After the loss of the Star Ariel, the entire Tudor IV fleet was withdrawn from BSAA commercial passenger service. Both flights also crossed an area where radio range and search capability in the late 40s were limited. Finding wreckage from a sunken airplane in deep waters of the Atlantic without an exact crash position was then practically impossible. Aviation historians tend to treat both losses as mechanical or fuel failures aggravated by that technical difficulty of the time in locating wreckage in open sea, more than as a unified phenomenon that connects both events beyond coincidence and the shared aircraft model. It is worth noting, moreover, that no other Tudor IV disappeared before or after those two flights, despite having operated for years on regular transatlantic routes. If there existed some force proper to the area capable of bringing down aircraft, it would be striking that it affected exactly 2 examples of the same model, with the same known design flaws in a span of 12 months, and no other airplane of the dozens of different models that crossed the same area at the same time regularly. On December 22, 1967, Dan Burrock, a retired hotelier, and his friend Father Patrick Horgan went out to tour the Christmas lights of Miami Beach by motorboat, a little more than 1 mile from the coast, aboard the Witchcraft, a 7-meter vessel owned by Burrock. Near 9 at night, Burrock called the Coast Guard by radio. The propeller had hit something submerged. The engine was disabled. There was no immediate danger, but they needed a tow. They told him to fire a flare in about 20 minutes to guide the rescue boat to his position. The flare was never seen. There was no further contact. Despite a search that covered 1,200 square miles during the following days with the Coast Guard, the Civil Air Patrol, and private vessels, neither the 2 men nor the boat ever appeared. Popular versions describe a calm night and an inexplicable disappearance in the very sight of the illuminated skyline of the city. The meteorological records of that night tell another story. Winds of 18 to 37 kilometers per hour from the north and northeast, white-capped waves already 1 mile from the coast, forecast of seas of 1 to 2 meters, conditions sufficient to sink a small and immobilized vessel that could no longer keep its bow against the swell. Without an engine and without the promised flare to mark its position in the darkness, a white-hulled boat tossed among white waves was almost invisible to searchers, and any call for help was drowned out by the wind and the breakers. Exposure to the cold water of a Florida winter leaves, moreover, a very limited survival window. The disappearance, which occurred minutes from the coast of Miami, owes more to bad luck, rough sea and a flare that was never fired than to any anomaly of the Triangle. On January 31, 1921, the crew of the Diamond Shoals lightship off Cape Hatteras in North Carolina sighted a 5-masted schooner, the Carroll A. Deering, stranded on the sandbanks with all sails deployed. When they finally managed to board her, days later due to bad weather, they found her completely empty. The crew's belongings, food prepared in the galley, and even the ship's 2 cats were still on board. But the 11 crewmen had disappeared along with the navigation instruments, the ship's papers, and the 2 lifeboats. The mystery deepened when it became known that, days earlier, the schooner had passed in front of the Cape Lookout lightship, and that a crewman who was not the captain had shouted to the lighthouse keeper that they had lost the anchors, an unusual detail since that type of message was usually transmitted by the captain or the first officer. During the same weeks, several merchant ships in the area, including a tanker, reported sightings of vessels without lights or identification and possible piracy or smuggling activities linked to the illegal alcohol traffic of Prohibition, which led to a federal investigation that considered a mutiny, a kidnapping by pirates, or an interception linked to smuggling. A conclusive answer was never reached. The official investigation left several scenarios open. That the crew, fearing that the ship would break apart on the sandbanks in the bad weather, abandoned it in the boats and died at sea before reaching land. That they were transferred to another vessel under circumstances never clarified, or that some criminal episode at sea never proven explained their fate. The investigation also added a chapter of its own. A bottle appeared with a note claiming that a tanker or a submarine had boarded the schooner and chained the crew, and 3 handwriting experts initially agreed that the handwriting belonged to the ship's engineer, which triggered for months the hypothesis of a kidnapping by pirates or Soviet agents. Months later, the very man who had reported the finding of the bottle admitted that the note did not come from the Deering at all, but that he had fabricated it together with fishermen from the area, leaving standing only the meteorological explanation that the Weather Bureau had proposed from the beginning. Since the hull could not be saved, the authorities ended up dynamiting the remains of the Deering weeks later. It is one of the few cases in the Triangle catalogue that resists a closed explanation even after a serious investigation, although each hypothesis handled by the investigators points to human causes, however obscure they may be: storm, mutiny, or maritime crime, never to something supernatural. In September 1955, the yacht Connemara IV appeared adrift and empty, about 640 kilometers southwest of Bermuda. Popular versions present it as another inexplicable abandonment in calm sea. The meteorological records show that Hurricane Ione, the 4th Atlantic hurricane of that September and one of the most intense storms of an unusually active season, had crossed the area days earlier with sustained winds of up to 200 kilometers per hour reported by land stations and reconnaissance aircraft, and waves of up to 12 meters recorded in open sea. The storm's path took it from the Caribbean toward the north, passing near Bermuda, before turning toward the open Atlantic near Newfoundland. The Connemara IV, which apparently was moored or anchored rather than sailing at the moment of the storm, most likely broke loose and was dragged out to sea during the hurricane. Its crew, if there was any on board at that moment, was lost or abandoned the vessel long before it was finally sighted adrift. In February 1963, the Marine Sulphur Queen, a 160-meter tanker converted to transport molten sulfur in heated tanks, set sail from Beaumont, Texas, bound for Norfolk, Virginia, with 39 crewmen and more than 15,000 tons of cargo. The last radio contact came in the early morning of February 4th, when the ship was approaching the Florida Strait. Days later, it was reported as overdue, which triggered a search that covered tens of thousands of square miles and only managed to recover loose debris such as a life jacket, a foghorn, and a fragment of an oar with the ship's name, several of them with marks compatible with shark bites, without bodies, without intact lifeboats, and without a trace of the hull. The official Coast Guard investigation, after months of work, did not assign a single cause, but detailed several technically supported hypotheses, all centered on the ship and its cargo, none on the paranormal. An explosion of the gases released by the molten sulfur when shaken by the strong swell, a structural failure of the hull, already aged after its conversion, which could have split it in two, a capsize due to synchronous rolling in large waves, or a steam explosion when seawater entered empty spaces in the tanks. The meteorological records of those hours marked gusts of up to 85 kilometers per hour and waves of more than 5 meters near the ship's last known position, conditions under which an aged tanker with known structural fatigue and heavily loaded could fail without the need for any extraordinary explanation. On August 28, 1963, 2 KC-135 tankers of the Air Force took off from Homestead Air Force Base, Florida, on a classified refueling mission. After noon, both airplanes reported their position about 1,400 kilometers northeast of Miami and were never heard from again. Days later, 2 debris areas appeared separated by more than 300 kilometers of ocean, a detail that for years fueled the most cited version of the case. If the airplanes had collided with each other, how could there be wreckage from them in 2 such distant points? The question, presented as irresolvable, ended up turned into one of the favorite pieces of the Triangle catalogue. The answer was in the Air Force's own report, consulted directly in the archives of Norton Air Force Base. The second concentration of wreckage, sighted near sunset when the light makes it difficult to distinguish objects floating hundreds of meters below, turned out to be only algae and driftwood, not airplane fragments. The only area of real wreckage, identified by its serial numbers as belonging to both aircraft, confirmed what the Air Force itself maintained from the beginning and reiterated in writing in response to later inquiries. The 2 airplanes had collided in mid-flight while flying in close formation, too near to react to any deviation in heading. There was no mystery area. There was a human error of flight proximity, an official explanation documented from the first moment, and an erroneous citing of wreckage that, once clarified, had already made its way in the press. The list of losses attributed to the Triangle also usually includes 2 nuclear submarines of the United States Navy, the Thresher, sunk in April 1963, and the Scorpion, lost in May 1968. Neither of the 2 fits, strictly speaking, within any reasonable tracing of the area. The Thresher sank during a deep-diving test off the coast of Massachusetts, far north of Bermuda, after the failure of a pipe joint that caused an uncontrollable flooding, later confirmed by the analysis of the wreckage found on the seabed. The Scorpion, for its part, sent its last routine message about 400 kilometers west of the Azores, and its wreckage was located months later more than 700 kilometers south of those islands, at more than 3,000 meters depth. The underwater photographs confirmed its identity without doubt, although the exact cause of the disaster, possibly linked to a failure in one of its own torpedoes, was never determined with absolute certainty. In both cases, there was wreckage located, identified, and photographed. Nothing disappeared without leaving a trace, and both shipwrecks occurred hundreds of kilometers from any usual definition of the Bermuda Triangle, another example of how the geographical elasticity of the myth allows almost any naval loss in the Western Atlantic to be added to the list. The Gulf Stream crosses the area at speeds of up to 5 knots, capable of dragging debris, rafts, and even semi-sunken hulls hundreds of kilometers in a few days, erasing evidence before any search aircraft reaches the reported position. That same current, when colliding with cold air masses, generates abrupt weather changes, sudden storms, waterspouts, and fog banks that form with little prior warning. Something consistent with several cases where the perfect weather of the popular account turns out, when crossed with real meteorological archives, to have actually been a front or a sudden storm. A large part of the area also coincides with the Sargasso Sea, a region without coasts, delimited only by ocean currents, covered with extensive mats of floating algae. Since the age of sailing navigation, centuries before the name Bermuda Triangle existed, Sailors feared being stranded there for weeks because of the lack of wind, while the algae tangled in the rudder and the stillness fed stories of ghost ships immobilized forever. That centuries-old fear, documented in logs and travelers' accounts since the 16th century, functioned as the cultural substrate on which the 20th century version of the myth was later mounted, with more modern vocabulary. The region is also located on one of the main corridors of Atlantic hurricanes. Several of the mentioned cases that appear in the catalogues as inexplicable disappearances coincide, when crossed with meteorological archives, with documented storms that simply were not mentioned in the original press coverage or that later authors omitted when rewriting the account. There are also giant waves or rogue waves, walls of water more than 25 meters high, generated by the interaction between strong currents such as the Gulf Stream and swell from the opposite direction. For decades, they were considered sailors' folklore, until the direct measurement of the so-called Draupner wave in the North Sea in 1995, 25.5 meters high, confirmed their physical existence and opened a specific field of oceanographic study. A wave of that size can split the hull of a large ship in seconds, which fits several cases of total and sudden loss without a distress call. The underwater topography of the area is also extreme. The Great Bahama Bank is only a few meters deep over much of its extent, so shallow that the remains of a shipwreck can often be seen from the air, which in fact rules out the idea of total disappearance for many accidents that occurred there. At the other extreme is the Puerto Rico Trench, the deepest point in the entire Atlantic Ocean, with more than 8,300 meters. A ship that sinks in that trench remains, for the search technology of the mid-20th century, lost forever, without recoverable remains, without the possibility of inspection, simply because of the depth, not because of any mystery. A more recent geological hypothesis, developed since the 1980s, proposes methane hydrates as a partial explanation. Beneath the seabed along the continental margin of the area, there are deposits of frozen methane. If a deposit becomes destabilized, whether by seismic activity, temperature changes, or pressure variations, and releases a large-scale column of gas, the water in that area loses density drastically and may stop supporting the normal buoyancy of a ship, causing it to sink rapidly. That same gas, if it reached the surface and ignited or simply displaced enough oxygen, has been proposed as a possible explanation, although not proven for any specific case of the triangle, for sudden engine or instrument failures in airplanes flying over the area at low altitude. Laboratory experiments and small-scale field tests confirmed that the effect on buoyancy is physically real, although they also established that large-scale methane eruptions are, on the human timescale, geologically rare events. The hypothesis gained public notoriety in the 90s when researchers from American universities recreated in laboratory tanks the effect of gas bubbles rising under a scale model of a ship and documented on video how the vessel lost buoyancy and sank in seconds when crossing the column of bubbles. The experiment demonstrated that the proposed physical mechanism works, but it did not demonstrate that it had really occurred in any documented shipwreck of the triangle. The large methane hydrate deposits identified in the area off the east coast of the United States have remained relatively stable for thousands of years, and there is no seismic or geological record of a massive release coinciding in date and place with any of the cases reviewed up to this point. Added to all this is a pattern that repeats itself in almost all documented cases, regardless of the decade. Vessels or airplanes with poor maintenance or already aged, cargoes prone to instability such as molten sulfur, manganese ore or insecticides, damaged engines that reduced speed and maneuverability, inexperienced or disoriented navigation, delays by the companies themselves in reporting the lack of contact for reasons of cost or schedule, and searches made difficult by last contact positions that were too vague, since many accidents were only noticed days later when current, weather and decomposition had already erased almost all physical evidence. One of the most repeated claims holds that compasses behave erratically inside the triangle without logical explanation. The phenomenon described is real, but it is not exclusive to the area, nor does it have anything mysterious about it. It is common magnetic variation perfectly charted. A magnetic compass does not point toward the geographic North Pole, but toward the magnetic North Pole, located in northern Canada, about 2,000 kilometers from the geographic pole, and whose position slowly shifts over time. At most points on the Earth's surface, the direction toward each of those two poles differs by a certain angle called magnetic variation or declination. Near the Azores, that angle is about 20 degrees, near Phoenix, Arizona, about 14 degrees. Navigators routinely correct that difference with values printed directly on any nautical or aeronautical chart. There is, however, a line called the agonic line, which runs approximately from the magnetic North Pole southward, crossing the Great Lakes region, the eastern United States, Florida, Cuba, and part of South America, along which the true pole, the magnetic pole, and the observer are aligned in a straight line. On that exact line, magnetic variation is zero. The needle points to true north without the need for any correction. Florida lies almost exactly on that line. This means that a navigator in the portion of the supposed triangle near Florida who forgets to apply the magnetic correction will not suffer any error, exactly the opposite of a dangerous anomaly. It is, in fact, one of the few places in that part of the hemisphere where skipping the correction has no consequence. The same geometry of the agonic line, applied with the same rigor, implies that compasses near Florida point with equal precision toward the small city of Kalamazoo in Michigan, since it is also located on that line. Presenting that geometric coincidence as a sinister anomaly is a rhetorical choice, not a physical fact. There do exist, at different points on the planet, genuine and well-documented local magnetic disturbances caused by mineral deposits, volcanic rocks, or solar storms that affect the upper atmosphere. But the instrumental records gathered specifically over the Bermuda Triangle by Navy research projects, such as Project Magnet, which used aircraft equipped with high-sensitivity magnetometers, found nothing in the area that does not appear to a similar or greater degree in dozens of other oceanic regions of the planet. A very similar legend exists off the coast of Japan, the Devil's Sea, feared for generations by Japanese fishermen because of unexplained losses attributed in ancient times to small vessels sunk by common storms. International attention on the area grew after 9 fishing and research vessels disappeared there between 1950 and 1954, several of them with good weather reported and almost no distress calls. The Japanese government investigated the area. The case that attracted the most attention was that of the research vessel Kayo Maru No. 5, lost in September 1952 with 31 scientists and crew members while studying an underwater volcanic eruption on Myojin Reef. It was determined that the vessel had been struck directly by that same eruption it had gone out to observe or by the wave associated with it. Unable to attribute all the losses to volcanic activity, but also unable to find a single alternative cause, the Japanese authorities formally declared the Devil's Sea a danger zone, an administrative recognition of real and varied risks, not evidence of a unified mystery. That pattern repeats itself around the world. Those who catalogued similar zones under the label of vortices in the 1970s came to list a dozen comparable areas from the South Atlantic to the Indian Ocean and polar regions. Almost all coincide with corridors of intense maritime or air traffic, which by definition concentrate more activity and consequently more accidents than empty stretches of ocean where almost no one navigates and where, therefore, nothing is ever reported as lost. The comparison is revealing for another reason. The Devil's Sea and the Bermuda Triangle share a characteristic that is rarely mentioned. Both ended up officially identified as areas of greater risk, one by order of the Japanese government, the other only in the popular imagination, after a handful of specific losses occurring in a brief span received simultaneous press coverage. In neither case did that coverage derive from a real and sustained increase in the accident rate of the region compared with previous or later decades. It derived from the temporal coincidence of several events that, told together, seem to form a pattern that time, examined more calmly, ends up dissolving. Now then, the complete catalogue of mysteries around the Bermuda Triangle reveals a consistent pattern, not of a physical phenomenon, but of narrative construction. Most of the incidents, once enough original documentation is recovered, have a plausible and not at all mysterious explanation. Bad weather omitted in later accounts, known mechanical problems, unstable cargoes, human error, or simple navigation failures, as in several of the cases reviewed before. The few cases that remain not entirely resolved are, almost without exception, those from which little or no original documentation survives, which left writers free to fill in the gaps with invented detail. The Carroll A. Deering is one of the few that remains honestly open even after a serious investigation. Several incidents habitually cited as triangle losses did not even occur near it. The German freighter Freya appeared abandoned in the middle of the Pacific Ocean, and a Globemaster airplane of the United States Air Force crashed near Ireland, but both ended up included in triangle lists by authors who worked from secondary sources without verifying the real location of each event. Added to this is the fact that the limits of the triangle vary enormously from one author to another, some extending it over much of the western North Atlantic, and with such an elastic region, almost any Atlantic accident can fit into it after the fact. In several cases, moreover, the only thing known about the lost ship or airplane was its last confirmed position before setting sail, and the fact that it had not reached its destination, so that a disappearance that occurred at any point along a route of thousands of kilometers ends up being presented as an event much more localized and ominous than it really was. Many incidents, on the other hand, were not even considered strange at the time and received only routine local coverage. Only years or decades later, when some author reviewing old archives needed to add new entries to his triangle list, were those common losses reframed as inexplicable. Contrary to the calm sea described by almost all popular versions, the meteorological records of the time show bad weather, including documented hurricanes in a striking number of these events. A good portion, moreover, occurred late in the afternoon or at night, which delayed any visual search until the following morning and gave the current many extra hours to disperse the remains before anyone could search for them. The authors who wrote about the triangle from Gaddis onward, to a large extent, recycled the research of those who preceded them instead of tracing original sources, so that a single early error or an invented detail once published was copied book after book, article after article, gaining apparent authority only by repetition. In a handful of cases, the authors themselves seem to have deliberately omitted information that pointed to an ordinary explanation, because a solved mystery makes for a far less attractive chapter than an unsolved one. To that scaffolding of errors and omissions were added over the years explanations increasingly distant from any verifiable evidence. Portals to another dimension, inverted gravity fields, extraterrestrial craft that collected crews to study them, and even energy crystals from Atlantis still functioning beneath the seabed. None of those hypotheses provides a testable mechanism, nor explains, moreover, why a supposed phenomenon capable of making airplanes, ships, and submarines alike disappear never left a single eyewitness, nor a single scientific instrument that recorded it, despite decades of constant traffic and research projects specifically designed to detect anomalies in the area. The more extraordinary the proposed explanation, the less necessary it ultimately became, since almost all individual cases were resolved as soon as they were compared with the weather, mechanics, and geography of the exact day on which they occurred. Taken together, these patterns describe less a region of the ocean than an editorial process. A story built piece by piece over decades of pulp magazines, paperback books, and television specials, each new version adding atmosphere while discarding the inconvenient data that would have closed the case. Kusha himself, after 3 years of reviewing archive by archive, reached a simple methodological conclusion. Looking for a single cause for all the disappearances of the triangle made as much sense as looking for a single cause for all car crashes that occurred in the same state over the course of a century. As soon as that search for a common denominator was abandoned and each incident was investigated separately, most of the cases stopped seeming mysterious. Neither the Coast Guard nor the United States Navy recognizes the Bermuda Triangle as a special risk zone, and neither of them keeps a separate record of triangle incidents, distinct from the general accident statistics in the Atlantic. Lloyd's of London, the maritime insurer that has recorded ship losses around the world for centuries, has pointed out on different occasions that it does not charge higher premiums to vessels that cross the area, since its own loss records do not show a concentration of incidents statistically different from that of other equally trafficked ocean corridors. Maritime and air traffic in that strip of the Atlantic is, in fact, one of the densest on the planet. Thousands of commercial ships, cruise ships, recreational vessels, and commercial flights cross it daily without incident, in a region also subjected to frequent hurricanes. intense currents, abrupt changes in depth, and constant traffic for more than a century. That a percentage of those crossings ends in accident is not, when examined with the complete records, different from what would be expected for any oceanic zone with that volume of activity and those natural conditions.